Hi, everybody. Thanks for coming out on fairly short notice. But welcome to the Austin DevOps Meetup special event. We're going to be talking about Habitat, which is a new thing from Chef. And Nathan Harvey flew in just to talk about this.
Just to come and eat Paul's barbecue, actually.
Oh, yeah. We're like, hey, Paul, we need something to have some barbecue at. And he said, write some software. So... So we did. Couple quick introductions. I'm Matt Ray. I'm the Director of Partner Integration. I'm based here in Austin for a little bit longer. And Nathan Harvey is our VP of Community from Chef. And we'll be tag teaming this thing and talking about Habitat. Please ask a lot of questions. It's new. We haven't road tested too many presentations. So this may be the first time this deck's been used in the wild.
Yeah, as far as I know.
That's the first time I've given it.
All right, thanks, Matt. Hello, everyone. So also we're going to be recording this, and we'll post it on YouTube, which is also great because this is, like as Matt just said, like one of the first times we've ever given this presentation. So it's always best the first time you do something, you should totally videotape it and put it on the internet. Like that's definitely the right thing to do. So I don't know if Matt remembers this, but at the very first Chef Conf, he and I co-presented on the same stage also. Did you remember that? We didn't actually co-present. We had two talks that were in the same session on the same stage. You were talking about Spice Weasel. Anyone remember Spice Weasel? Yeah, Spice Weasel's awesome.
Rackspace uses it in production.
Oh, Rackspace uses it in production. That's amazing. That's great. That's great. So the reason I'm using a mic, I almost never use a mic at meetups, but we are recording this, so this will help with the video quality and the audio quality. Probably it'll help better with the audio quality, if I'm being honest, than it will with the video quality. But that's cool. I think we're gonna do something with the lights also, but I'm just gonna. I don't know where I can move. I'm gonna move around, and if I walk out of frame, you will all still be able to see me. So is that okay if I walk out of the frame? You guys don't care, right? Yeah, I don't want to look at myself. That just gets awkward. I might start talking to myself back there. I don't know. That would be bad. Yeah, I see it. Okay, so there's another issue. Like I have a remote and a microphone and a beer, but I only have two hands. I don't know what I'm gonna do here. So anyhow, I'll put the beer down. I might regret that immediately. I do. That is a little more professional, though, isn't it? But this is a meetup. So, all right. So this is a meetup. Thank you for coming out. As Matt said, this was on very short notice, and it's awesome to have you all come out tonight. So how many of you, this is your first time at Austin DevOps? Wow. That's all. Oh, I should raise my hand, too, because it's my first time here also. That's awesome. Welcome. How many of you, this is your first time to a meetup? Anyone? Seriously? That's awesome. We have to give him a round of applause because this is his first time at a meetup. Look, think about it. Think about the first meetup you went to. Probably someone took you there or you weren't very comfortable about going, and we're glad that you're here. Going to meetups, like my job as being in charge of the community for Chef is to tell people go to meetups. And the look I get when I tell people that is, after work, you want me to go to work. I don't understand. Why would I want to do that? I want to go to pub or to family. But no, you took the right step. You made the right choice tonight. Forget your family. We have beer. It's fine. And delicious, delicious barbecue. So thanks for coming out. My name is Nathan Harvey, as John so helpfully pointed out. I've misspelled my name. The truth of the matter is my father misspelled my name. And the way that it worked in my house was mom picks the names, dad misspells them. Because my father was a brilliant visionary in the early 70s. He knew that one day all of his children would need a unique way to identify themselves on the web. So he named us all, or spelled our names all incorrectly. You can follow me on Twitter. Oh, actually, I did spell my name wrong. Is that the name that you were saying I spelled wrong? The actual name that I misspelled? It's cool, because it's continuous delivery. Just hit escape and fix it for me, please. It would be terrible if we didn't fix that. This is on video. We have to make sure it's accurate. All right, there. Now my Twitter handle is spelled properly. And you may have heard my phone going off. So I used to be on call. Right? I used to have a real job before I was a community manager. And when I was on call, probably not unlike some of you, like when that pager goes off, you get that rush of adrenaline. Like, yes, I get to be the hero and save the day. And then you look and the alert is meaningless and you don't have to do anything except go back to sleep. But I miss that buzz. So sometimes when I give presentations, I tell people my Twitter handle, and then I tell them that I'm going to leave my phone on, just so that I can show you what a great person I was on call, how well I can ignore all of the interruptions from my phone. That's how I knew I was a good professional sysadmin. I was good at being on call when I could ignore my phone. I have done this before, and as I've been explaining this in the past, my wife was calling me one time. Actually, that's not true. It wasn't while I was explaining it, but I was on a slide, and the slide, no lie, said risk. And the phone rang, and I looked down at it. I'm like, yeah, I'm totally not even going to answer it. Oh, it's my wife. Well, the slide's apropos. I'm just going to keep talking, and that's a risky move to not answer the phone when your significant other calls. Anyhow, you didn't come here to hear, well, maybe you did come here to hear stories from me, because I'm going to tell them all night, so I hope that's okay. But what we came here tonight to talk about was Habitat. How many of you watched the release video, either on Tuesday or since Tuesday? Okay. How many of you are like, what release video are you talking about? How many, okay, one or two of you, that's cool. How many of you have watched a video with me in suspenders before? That one is a lot of fun also. Yeah, more people have watched the video with me in suspenders. I feel pretty good about that. That's cool. So Habitat, what is it? We're going to talk all about Habitat tonight. Both Matt and myself will even do some demo stuff if you'd like. And we do absolutely want to answer a bunch of questions. Maybe I should also ask, how many of you are familiar with Chef? Okay, great. Good. That's a good large number, because we're going to make some assumptions that you know at least a little bit about Chef, sort of the space that Chef is in and so forth. So on Tuesday, we announced this brand new thing called Habitat. In the release video that I'm talking about, you can go and watch it. It's at habitat.sh. That's the website for Habitat. It's a new open source framework that's all about application automation, which is maybe not a term you've heard before. Maybe it is. We're going to describe what that is all about over the next 50 minutes or so, something like that. But you can watch a 1-hour video that kind of talks about what it is from our CTO, Adam Jacob, who also was one of the big creators of Habitat. And it includes a demo as well. I'm sure that demo will go almost as well as the demo that Matt and I will do later tonight. So, but you're here for the real thing. What I recommend you not do right now is go on your phone and pull up Habitat.sh and start watching that video, because we're here in the room and you should watch it with, you should do it live, because that's better. So Chef, configuration management, this is where we were born. This is where Chef was born. This is the thing that we love, and we still love it today. Just because we've announced a new product doesn't take away any of our love for configuration management. It's a beautiful thing. I fondly remember the days in my past. Like, there is one specific day, speaking of being on call and being a sysadmin, I remember the day I became a professional sysadmin. The day I became a professional sysadmin, I was taking a shower. That's as detailed as I'll get about that part of the story. And a thought occurred to me in my head, and that thought was, the next change I make to a production system will start with a commit to a Git repository. That day I knew I became a professional, right? It was no longer was it that what I was going to do was log into a server and change something and make sure that it worked after I was done changing it. But I remember that morning realizing that configuration management was a real thing, automation was a real thing. Chef taught me how to be a professional sysadmin. Do any of you remember a similar moment in your own past or history? It's pretty powerful stuff when you get there. It's also very freeing. I feel like I could do my job much better then. There are many different configuration management tools out there. And frankly, I get asked a lot of times, why should I choose Chef over Puppet, over Salt, over Ansible? Which one should I pick? My answer forever has always been the same. If you're asking me, should I use Chef or Ansible or Puppet or Console or any of these things? My answer is yes. Yes, you absolutely should. Please stop logging into your servers on your own. Please stop trying to roll your own configuration management framework. Use the open source tools that are out there. It gives you the great benefits of leveraging the communities of people that are out there using these tools. You can get much better about your job. Now, all of these approach tackle this problem of configuration management a little bit differently. Frankly, at the end of the day, what matters is that you think critically about the problems that you're solving, and you leverage good frameworks to help you solve those problems. Now, that said, I might be just a skosh biased, but I do think Chef is the best of them out there. Yeah, it's cool because we get to write code also. That's a fun slide. But, you know, sometimes people tell me that learning Chef is kind of terrible, and learning Chef is hard, right? I'm a sysadmin at heart, and you're telling me I have to start writing code to do my job better. You're telling me I have to come and learn Chef. Well, learning Chef can be very difficult. It can feel like I have this huge learning curve that I have to go up. Learning any of these tools can feel like a huge learning curve. And it gets even worse, actually, I think, if you approach this problem as an application developer, not as a sysadmin. So sure, as an application developer, maybe I know how to write some code really well, but I don't necessarily want to think about things like a cloud environment or containers. I just want to write my application and be done with it. I just want to move on. But with these tools, of course, we want to automate all of the things. Automate all of the things. And how many of you, all right, so I'm not going to ask that question. I'm just going to tell you a little bit about myself. Back when I was first using Chef, the thing I was using Chef for was actually automating infrastructure that ran mostly Rails applications. We ran some Java apps as well, but mostly Rails applications. And we were really great about automating the system up until like the point where it was ready to have the application. But when it came time to deploy the application or push out that application code, we fought and struggled a lot. Frankly, how many of you run Rails apps? I said I wasn't going to ask any more questions like that, but I just did. All right, so we've got one person that runs Rails apps. How do you deploy those Rails apps, Paul? What's that? Pauly. Oh, poorly. Yes. All right. Yeah, it's that accent. I couldn't quite understand. It's too much barbecue. Fabric, Ansible, and Wishes. That's cool. When I deployed my Chef code, I did it with Capistrano. In fact, that talk that Matt and I gave on that same stage, I was telling folks how to use Chef and Capistrano together to deploy your Rails applications. And it was great. But the problem was I just wanted to use Chef. But the problem with using configuration management tools to deploy your applications is that they're really suited really well for managing your infrastructure and managing the state of your infrastructure. But when it comes to your applications, think about how Chef works. We typically will run Chef on a continual basis on our servers so that it is always checking in, making sure that the policy is being enforced, right? So let's say I want to go and deploy an application. Well, although Chef is running all the time, it maybe checks in every 30 minutes. And we don't want all of the servers at once checking in at the top and the bottom of the hour. So if we want to deploy our applications following that same process, it's really easy. You just have to be comfortable with the fact that over the next 30 minutes, some portion of your application servers will be serving the old code, and some portion will be serving the new code. How many of you write applications where that totally works every time? All right, two of you do. That's awesome. That's awesome. How often do you deploy? Once every 3 years. Yeah, that's cool. That's cool. But seriously, that becomes a really hard problem. And the way that we solve that problem is either by using tools that are outside of the tools that we're using to automate our infrastructure. So I used Capistrano at that time. Or we try to build a lot of intelligence into those configuration management tools to make that process actually feasible and make it actually work. But in doing so, we end up with a lot of complexity. And the other thing that this really forces us to do is think about that infrastructure when all we really want to do is deploy our applications. Do your customers care if your applications run in the cloud or in a data center? Your customers probably don't. They care about the application. They want it to be up and available and working. Another little thing that could be better with configuration management is centralization. Think about the way the Chef server works. So when I deployed my Rails applications as an example, the Rails application itself, the application tier, we wouldn't tell it what its database server was going to be. When the application was provisioned, it would ask the Chef server, where's my database server? And the Chef server would return that answer, and then that application would configure itself to talk to the database. It works okay at a certain scale. But as you grow in scale, as you grow in complexity, that centralization becomes a problem. Because now what happens if the Chef server is down? What happens if that central authority is unavailable? What if I can't actually connect to that thing? What if the data isn't there? And worse, what if the data is out of sync? What if I'm making a request and immediately after I get the response, the information changes? And so now I'm pointing at the wrong thing. That can be a real problem and certainly something that we look to improve. Who's using immutable infrastructure? Heard of this term? Immutable infrastructure, right? This immutable infrastructure, like it sounds like the right promise. What I want is to build an artifact that does not change. It's fully immutable. And I can run that artifact in my development environment. I can pick up that immutable artifact, unchangeable artifact, move it to my test, move it to my production environment. How many of you think that that's like feasible without a whole lot of complexity? Think about running your application in production versus running it in the development environment. Yes, you want the same package, you want the same bits, but it must be configured differently. How many of your laptops have the same size and scale and number of apps as your production environment? Like it's not the same. The problem gets more and more complex as you get closer to production. The idea of the immutable artifact is brilliant, but the reality of it and how we actually implement that is something that could be better. Hidden dependencies. Hidden dependencies have never actually bit anyone in the past, I know from experience. Especially like, I don't know, there's never been like articles where the entire internet blows up about, I don't know, some package being removed from some node repository or something and it just breaks every node app. Like that would never happen, right? Because we won't depend on things that are off on the internet. We'll know very well about all of the dependencies that we have in our applications. We need to have better visibility into what are our dependencies and better control over them. Orchestration. Orchestration is great. This is a real problem. Like how do we tackle this orchestration problem? When we take tools that are in the traditional configuration management space, can we do orchestration with Chef? Sure we can, but it gets pretty complex when we go and do that. We have to write a lot of custom code to make that orchestration work. And when I'm talking about orchestration, really there are a bunch of different use cases around orchestration. Sometimes orchestration might be how you deploy your applications that sit behind a load balancer. So think about how would that process work? Well, I'm going to deploy a new app or a new code to an application server. So before I deploy that code, let me first take this one application server out of my load balancer, deploy the new code there, do some sort of testing against it, make sure that it works, maybe pull another one out, put that on the new code, do some testing, and then eventually, like I'll have them all out of the load balancer, maybe served up under another load balancer. That problem can be pretty complex to model. How do you model that orchestration? And so what we really need that's better than orchestration is think about this in terms of choreography. We really need the actors in our system to be autonomous and to understand how they should work. And actually, I think this slide is a really apropos way to describe this. If you think about the Rockettes, how many of you have seen the Rockettes at Christmas? All right, how was it? It was great. I mean, it's got to be pretty amazing to see, I don't know, 150 women up on stage doing all of this choreographed dancing. I mean, it's got to be, like, it's an experience, I'm sure. Like, they're all in sync, right? And do you know why they were in sync? It was because of orchestration, because there was one person in the front who was like, all right, you kick, you kick, you kick, you kick, you kick, right? You can't do that with orchestration. You can't have an actor that is pointing to them and telling them when it's time to kick. They need to know and be able to adjust based on the dancers on the left and right of them when it's your turn to kick. You need to have the policy, like you need to understand it's my turn to kick, like when that leg goes up, my leg comes up next and then hers is going to come up. If she's feeling a little tired today and her leg comes up slower, I need to adjust to that and I need to pause for another second so that we can stay in sync. And think about this in terms of your applications. Like the metaphor is strong. You want your applications and the components of your infrastructure to know enough about how do I take care of myself? How do I participate within this community? What are the rules that I have to follow and how do I enforce those locally? And how do I keep track of what's going on around me? Application release patterns could certainly be better. How many of your application release patterns look like this? This is pretty, another great slide here. So releasing your applications can be very, very difficult. It can be very complex. One of the things that we find with application releases is sometimes you'll automate 80% of it. And then the last 20% you have to do in manual steps. And you have to do them in the right order, standing on your right leg, hitting the keyboard over your shoulder, right? You have all these special incantations to make sure that the production systems stay up, that the code gets out there in the right way. So this idea of how do we do a sane or a reasonable application release pattern can be difficult. The tool chains that we use can be very complex also. How many of you use one tool every day and only one tool? Just use Chef. JJ just uses Chef. Thanks, JJ. You're awesome. You should start using Habitat now, too. There, now you have 2 tools. You're welcome. I just made your job twice as hard. It's cool. No, but our tool chains can be very difficult as well, or not necessarily difficult. Like, you love the tools that you use. I hope you love the tools that you use. If you don't love the tools that you use, learn to love them, because they're the things that are going to make you productive. But we have so many different tool chains, and of course, the context switching that we have to do as we move from one tool to the next can be a problem as well. So, what if we took a step back? And this is how sort of Habitat came into being. We took a step back and we said, all right, well, there are these problems. How could we address these? What could we do to fix all of these? And what if we took a step back and thought about the applications that we're building? Like, at the end of the day, the infrastructure that you build only matters because of the applications that run on top of it, right? If you sit around and build the most amazing data center with the coolest gear in it, but no applications run there, who cares? You might care, and I bet you could find some of us that would think it was pretty awesome, but we're not going to buy anything from you, right? But it's also true that the applications that don't run on good infrastructure, or on any infrastructure, like, who cares about those? How many of you have ever bought something online? Come on. Come on. Yeah, you've all bought something online. Oh, but there's a second part to the question. How many of you have ever bought something online through the application that runs on the laptop, and only on the laptop of the developer sitting in front of you? Like, how do you do that? That's not really online. Like, if it works on my machine, that doesn't matter. That application needs to be on infrastructure. The infrastructure and the apps, they really go together. But what if we thought about the application problem? What if we thought about this from the customer's point of view? Whoa. So what if we built for choreography instead of orchestration? What if it looked like this, where we have a database change? The database change starts like a schema change happens. And as that schema change happens, what if the database was able to tell the application server, hey, I'm going into maintenance. So application server, because I'm in maintenance right now, you need to start serving up like temporarily down or have some degraded service that's happening there. And you need to tell the web server to start serving up like the under maintenance page. But what if instead of us starting there and telling Nginx put up the the maintenance page and then tell our application server and then run the database? What if when the database change started happening, the system just took care of itself? That might be a lot better. All right. Oh, sorry. The things are starting to go away. So the database change is done. The database should tell the system, hey, I'm done with that change. Application server, you can start connecting to me again. The application server can validate that it connects to the database fine. And then it can tell the system, hey, you can start serving web pages to me again, or I can start serving up application requests. So now the site comes back online. And what if the system took care of itself as it did this? And what would it look like if we built for large distributed systems that are topology aware? So these big distributed systems that knew about all of the other components within their systems. What if we built a way to run immutable systems with flexibility and ease? What if we could keep those same bits identical from dev to test to production, but have a nice way to inject configuration parameters? Where's the database? That's something that's going to change. That configuration has to change as you move from one environment to the next. How can we keep that package fully immutable, but inject those configuration parameters? What if we found a way to strip out hidden dependencies so that when you built those packages, you knew what all those dependencies were? And not only did you know what all those dependencies were, but you were able to package them all up so that all of those dependencies became one package. And what if we had a simplified tool chain to do all of this? That would be pretty good. And that's what we built with Habitat. These are the problems that we were trying to address, the things that we want to make better. Habitat, as I've just told you, is about 3 days old. So you're getting in on the very early access of Habitat. We're really excited to talk a little bit more about actually how it solves those problems. And what we're really most excited about is to hear your feedback about Habitat. We want you to put your hands on it. We want you to get some time working with it. So as I talk next about Habitat, I just want to remind you that configuration management is not dead. Like, Chef is not going away. We are not throwing out everything to do with Chef and saying it's only Habitat from here on out. In fact, Chef and Habitat are very complementary to one another. If you think about tools like Chef as configuration management, as automating your infrastructure, maybe even automating some of the compliance of your infrastructure, that is a problem that still exists today. It is a great thing that you can use Chef to help solve. When it comes to your applications, though, the application automation, that's where Habitat is going to come in. So it truly is your applications and your infrastructure working together in harmony, and that's configuration management. It is not dead. So let's look at Habitat. So Habitat has a couple of components, and these components were all built with those ideas in mind. How do we solve for some of those problems? So the first thing that we have is the Habitat Studio. The studio is a clean room environment. It's just enough of an operating system that it has actually no dependencies built into it. And within the studio, you are going to build the immutable artifacts that are your application. So you're going to describe exactly what your application needs, both in terms of dependencies, in terms of how that application works, how do I initialize that application, how do I run that application, what configuration parameters are available. I'm going to describe all of that within my studio and then create a package from that. The reason we use this sort of clean room studio is we don't want to inject any hidden dependencies. We don't want anything that's in that package to be unknown. It should all be declared as part of what we call the plan for that package, which is the next part. So the plan is how do you download, compile, and install that thing, that package? How do you run that application? And then, whoa, that was a little quick. So then we have this place called the Habitat Depot. This is where you can take those packages that you've created and publish those packages. So to start, just with these three things, Habitat is a new packaging system. So Habitat is going to be a system that will create those immutable artifacts. Those immutable artifacts are your application. And we're going to look at what those plans look like. We'll actually build a plan, we'll build an artifact and show you how that works. Now, in addition to being able to build those artifacts, like that's one thing. We have this immutable artifact. It is built in a way that allows us to inject configuration parameters, but we need a way to actually inject those configuration parameters. It is built in a way that allows your systems to be topology aware. But the thing that does that is this other bit called the Habitat Supervisor. So the supervisor is responsible for how these packages actually run. It can take and inject configuration parameters. It can decide, hey, this group of packages work together in a cluster. Maybe it's a Redis cluster where we have to have 3 or more Redis machines in this cluster. They're topology aware. One of them will be the leader. The rest will be followers. There might be an election as nodes come in and out, or as Redis environments come in and out of this Habitat. So the supervisor is responsible for managing all of that. And we'll look at some of the technical ways that it does that. It also has this discovery, service discovery, automatically built into it. So go back to that Rails application that has to talk to the database. The supervisor knows where that database is, or can describe and allow you to discover those various services. That slide, I don't know. I think it's the curse of Jay Timberman that's making those slides go crazy there. So Habitat artifacts have a .heart extension because we love you. Thanks, Joshua. It's good to have Joshua in any presentation that you give, I think. So let's talk about this. And what I'd like to do here, Matt, I think I want to give a high-level quick walkthrough here, and then we'll do demo of how to build a package. So we'll start with just the package format. So there are a lot of words here. It's probably best if I'll give you the high level 20,000 foot view of what we're going to do, and then I'll let Matt drive the demo, and he and I can talk about what he's actually doing. So the first thing, when you want to package up an application, package up a thing that you want to deploy, it starts with a plan. Now, the plans are written in a language that you might be comfortable with, you might be familiar with. Has anyone heard of the language Bash before? Bash, yeah. We write in bash. It's kind of weird. What's that? Wow, yeah. Do you know why we write in bash? Like, one of the sort of core tenets and beliefs around Habitat is we want to make this easy for everyone. And we don't want to add too much abstraction, so much abstraction that it just gets lost and you have this really steep learning curve. So bash makes things very simple. Everyone can type and can write bash. It's also, if you know anything about Chef, like that's way different than writing Chef. We're gonna write a bash, a plan in bash, not a plan in Ruby, a plan in bash. What's that? Not the way you write Chef. That's why you use Ansible now. Okay, so packaging starts with a plan. A plan it's simple to create. In fact, as the slide says, a plan is as simple to create as a Docker file. Who's ever created a Docker file before or read a Docker file before? Like, they're pretty simple, pretty easy to create. I should say also that Habitat is not a replacement for Docker. I'm going to say those words again. Probably 3 more times tonight. Here's the second time. Habitat is not a replacement for Docker. Okay, so we'll see how it works really well with Docker, though. So we're going to start by launching an isolated build environment. That's the studio, the Habitat studio. And like I said, this is sort of the clean room, and we're going to have Matt do that in just a second. We're going to do a couple of things in that studio, and then we're going to build an artifact while we're in that studio, and this is that immutable package. From there, we can post-process that artifact if we like, and we'll look at an example of that, maybe. And then we'll run and test that artifact. So Matt, maybe you can just take over on your computer. You'll have to just remember that you have to switch the, yeah, there you go. All right, we saw it there. No, I think your mic is not on. All right, so while he's turning on his mic, he's running a command called hab studio enter. So actually, Matt, sorry, before you get there, what's this hab command? How did you get that installed?
So if you go to habitat.sh, there's a download link on the page. Habitat is written in the language Rust. Rust is a fairly new systems language, came from Mozilla. They wanted to write a safer version of C++ for writing systems tools. We looked at Go. I think there's a lot of good things about Go, but for our use case, Rust was a little fit better. I think there's supposed to be a blog post coming out from Adam about why he likes Rust. Last year, he wrote an article about Rust versus Go. You know, they're both good languages. They both fit that niche of creating a binary that's portable without a lot of system dependencies. So Habitat, you can go get yourself an OS X binary or go get a Linux binary, and it's small. It's about 3 megs. So Hab. I typed Hab Studio enter, and that entered me into this clean shell. There's nothing in. I'm running Docker engine on my laptop here, and Habitat Studio entered a Docker container that has a BusyBox shell. That's it, and libc. You know, so there's nothing in here. It's mounted on top of my current file system. So I've got my Habitat plans here, and we can see if we say ls plans, we've got a bunch of stuff there. So these are the plans that are currently packaged with Habitat. And so let's take a look. I'm not gonna vim plan sh like the instructions say. I'm gonna use Emacs. But hopefully you guys have done the tutorial. So we'll skip ahead to something I wrote because
Has anyone done the tutorial?
Yeah.
All right, a couple people have. Cool.
So the tutorial walks you through a Node application. Speaking of hidden dependencies. Yeah. And there may be a bug in the tutorial around hidden dependencies. But anyway, so I'm going to do Polypo. Polypo, if you haven't used it, it's a caching proxy. So maybe you've heard of Squid. Polypo is a C app, and it's really small, really simple to use. So I needed to add some proxying to my build environment because I had terrible internet. So I wrote myself a polypo plan. And so first things first, we've got our package name, polypo, fairly straightforward there. This is a core package now. I wrote it, but seeing how I work at Chef, I pushed it into core. The current release version is 1.1.1. The license on polypo is MIT. The source code is up on GitHub. And if you're familiar with GitHub, you can get things that are tagged as releases. You can go and get yourself a tarball or a zip. In this case, I'm going to this JECH, the user who wrote it, and grabbing polypo from the archive. And I've got this templatized source where it's going to take the package name polypo and the package version 1.1.1 and go grab that that tarball for our source. I've got the MD5 256 SHA sum there, and we want to make sure we're getting the right package off the internet because you don't want to trust just any old thing off the internet.
Yeah, it's kind of important to make sure when you have in an automated build, go grab a thing off of the internet and then run it. You want to make sure that you're getting the thing you expected for sure.
Because so the build dependencies, because this is a C application, it's GCC and make. You might say, well, I've probably got GCC or make on my system. No, you don't. You don't have it because this is a clean build environment. You want to make sure nothing infiltrates it. And then we have our package dependencies, and it's just libc. There's nothing here that needs to be bundled with it. I don't need to say, A, it needs a JVM or, NPM or anything like that. So nice and simple.
And the difference there between the two is as you build the package, what do you need on your system? And then the package dependencies are your runtime dependencies. So what is required for this thing to actually run? And as you know, the difference, there may be differences in what you need to build. You may need more things to build the thing than you need to actually run the package at the end.
Yeah. And on these dependencies, I'm actually being a little bit lazy. I could specify that this only works with GCC 2.2.22. Version 6.7.1, I can get as fine-grained on that dependency as necessary because I'm pulling the GCC package from Habitat that it's a core package. We have multiple versions of GCC available. So perhaps, I'm saying 2.2. I don't know what the current version is, but let's say that 2.3 introduces a bug that breaks C applications because nobody uses GCC for that. And so you're like, oh, I need to pin that. So I could actually come here and say 2.2.2 or something like that. I can actually go farther if there's a specific build from a certain day that I need to get. I could also change out the core, and I could say, Nathan Harvey's got a really great GCC. I love his. So I'm going to use the one he built.
It's pretty awesome. You should use it too.
Yeah. It only does C. He got rid of all that junk I don't need, like Fortran. So you can these are fairly generic, but you would actually probably get very specific if you need to pin those sorts of things down. So we list the bin directory where our binaries are going to be installed. There's bin or sbin or user bin if necessary. The include directories if there's anything that needs to be included, lib directories, and any sort of exposed ports that I need to open. Polypo listens on 8123. That's configurable, but I'm just saying, hey, by default, this application is going to be listed on 8123. I can list multiple ports if I don't know. I was using multiple ports for this application, but I'm not. The directory, and then there are a lot of overrides available. So this is all included in the documentation. But when you go to build something, sometimes when you untar it, it ends up in polypo, I might say, tar-xzvf or whatever, and it throws it out into a polypo directory. Sometimes it might say, oh, it's polypo.1.1.1, or polypo source-1. So sometimes you need to futz with the name of that. So we make it available to you. And then we have the build command. By default, I'm not sure what the default is.
I'm pretty sure that default for a build command is going to be configure make install.
Dot slash configure.
Yeah, dot slash configure.
That's not what it is for polypo, so I had to change it and override it. And then for installing, polypo doesn't have a make install, so I have a make install command that I've written by hand here. Make the directory and copy it to it, because all it does is throw out a binary and says, "Hey, look what I built," and that's great. It's a simple app.
And so that do build and do install, these are hooks that are predefined as you build out your plans. And so you can override the predefined hooks, which is what Matt has done here with both the do build and the do install. And then the weird thing that I remembered and was kind of schooled on, the first time I wrote a habitat plan, I wanted to override the do build. And what I wanted to do was have the build do nothing. Because all I needed to do was unzip the package and move it. That's all I needed to do. There was no make involved. And so I'm a good programmer. I said, I just want this function to do nothing. So I said, do build, open, close, paren, open, close, curly brace. There, it does nothing. And it failed. And I asked my coworkers, I'm like, why did this fail? And they're like, dude, you're not writing a language. You're writing in Bash. You just wrote a bash function. You should exit 0 if you want it to do nothing or do something else within that. You're not writing Ruby anymore. It took me a minute to remember that this plan.sh is not plan.rb. And I just wanted it to be plan.rb. So embrace the fact that it's bash and it's pretty awesome. Yeah.
And there are lots of examples if you need to see how certain applications are built. This is HA proxy. It's got its own funky build commands, but the fact of the matter is we chose bash because that's what people do their builds in. So coming back to polypo. So that is the plan for polypo. It's fairly simple. And so polypo's got a really straightforward, simple configuration. It has a .config file, a polypo config, and it is simply the config and what you want it set to. And who's used a templating language before, like ERB with Chef? We're using Mustache, which is a very simple templating format. And so we're defining our defaults, things that are exposed for configuration, in this TOML file. TOML is, was it Tom's markup language?
Yeah.
So it's pretty simple. You say what you want and what it's equal to, and it lets you have comments in there, and that's pretty much all you need. You can put logic in your TOML if necessary, and we'll see. I can find an example of that quickly, but here I'm just saying, hey, these are the things that are exposed for configuration. The ports. These are settings that Polypo uses. I'm turning, which DNS to use, how long to keep packages around, how much stuff to store in memory. If you're using Polypo, you might say, oh, these settings are not very secure. Well, it's because I'm running it on my laptop to cache builds. So I'm not worried about the internet using my builds. But these are the things that are exposed. And then what Mustache is going to do is take those settings, turn them into the template substitutions, and build this Polypo config file. So when Polypo runs, it loads up that config file with whatever's been set. Okay.
So if we were to compare this to Chef, right? The TOML is like your attributes from Chef. But one of the things that we learned from Chef was if you get too fancy with your attributes, man, it can be real pain, right? Has anyone ever been bitten by the 18 different levels of precedence at which you can set attributes in Chef? Yeah. Either you've never used Chef or you're lying if you didn't raise your hand. Let's be honest, right?
Nobody uses all 18.
Yeah, nobody uses all 18. That's true. You didn't get bitten by all 18 of them. Fair enough. So we make this very simple here. You have the TOML file where you set those values, and then you have the template in Mustache.
And that's it.
That's it.
So if you want to go and build it, you say build, plans Polypo, and it goes off and says, hey, here are the things I need to build. So looking up at the top, we're loading our plan, calling hab plan build setup, which version of hab that we're using. Looks like I have an old version. And then it's going and installing GCC. GCC has some dependencies. I didn't specify my version of GCC, so it's going and saying, well, I just grabbed the latest, and here's what it's using, and here are the dependencies that GCC has, some Linux headers, some zlib, and GCC is a kind of a large package. I guess it's 5.2. I've been saying 2.2. And you can see that this version was built 2016, 6/12, so 4 days ago. And then install of core GCC is complete. The package is installed. I've resolved your build dependency, and this is where it installed it. Hab packages core GCC, and then it installs make and libc. Sets a nice long path for me. Everything is specified out to the individual dependency, whether it's gzip or wget or what have you. Long path. And then it's going and creating a source directory. Pulls down that tarball from GitHub, and connects to a polypo proxy that's already running. So then goes and pulls everything down, untars it, verifies it, untars it, builds it. Whole lot of GCC in, because that's exciting. A little warning in there. Goes and creates the polypo directory, writes our configuration, our scripts, builds the package metadata, signs the package, and publishes it, or writes it out locally, and creates our heart. There's our heart. So it creates the tarball, then puts the header of the signing header on it, so you know that it came from Matt Ray. I signed it with my own, I think. Or did I sign with the core? Yeah, I signed with my own. And then it cleans up after itself and installs it locally, and it's done. 31 seconds.
And I love it when a plan.sh comes together. Yes.
So that's pretty cool. I now have this tarball of a binary that it's portable. I can go and take this, I can untar it onto any Linux system running 2.6.32 or later kernel. So CentOS 6 and later. I think that's Ubuntu 12.04 and later. Yeah.
Yes.
The hard file. So you can go and take this and just slap it on a Linux box and untar it. That's kind of cool. I mean, if that was the only thing where you're showing you'd be like, that's kind of useful. I mean, I don't know why GitHub didn't write that yet, but somebody should have wrote a build system for me like that, because I'm not gonna, I'm not a Linux distro, but I have to build things and sort that out, and that's really handy. But let's say, should I keep going?
Yeah, sure. Okay. Let's keep going. Yeah.
So I've got this artifact. I'm like, but in reality, I'm going to run this on Mesos, or I'm going to run this on Docker, or I'm going to run this on Rocket. And so we actually support packaging those formats, and there's no reason we can't support more formats. Those are just what we had at launch.
So this is on that slide, it said post-processing your artifacts. So Matt is now going to take this artifact, and he's going to export it as a Docker container.
So this is going to it's connecting to our depot and getting the core hab package dockerize command, which, if you guys are interested, we can look at that too. But that's just a big bash script that puts together a Docker file, tears open that tarball, creates an empty file system, puts it on there, puts the Habitat supervisor with it, bundles it up, and when we can watch it, it's still going. So it's getting my Docker, creating an empty Hab Studio, so an empty file system. Getting the dockerize command, polypo sub, installing all the things that the Hab Studio needs to run, and boom. I now have a Docker container built from scratch of exactly what, that only runs my application. And so it's got polypo and a supervisor, the Habitat supervisor. Let me pop over to a shell. Gotta kill some polypos because they're already running. Now I want to Docker run port 8123, 8123, Matt Ray, or actually I can just grab this build number right here. All right, so now I'm actually running Polypo. I put it into a Docker container and I'm running it on a Docker machine. What we see here is a Habitat supervisor starting up, saying I'm running on this port. We're running the default service group. We'll get to the gossip ring here in a second and talk about that. I've updated the Polypo config. I didn't pass it any settings, but they're all there. And it started. So, everybody loves a live demo. So if I go to ta-da, Polypo. It's not super exciting, but it's running. And I can go. This is one of those insecure things I did. I exposed all the configuration. You can change it on the fly here, but
that's probably fine.
It's probably fine because it's running on a Docker machine on my laptop and not exposed to anything except for Habitat or myself. So that was pretty cool. I mean, I just built an application and Dockerized it, and I know exactly what's in it. Everything that I'm using can be traced to source, can be traced to GitHub. It's all signed. That's kind of handy. I could have, I did a HAB package export to Docker. I could have sent it to ACI, which is the
Rocket format.
The Rocket format. I could have sent it to Mesos and use the Mesos native container format. We plan on adding more. Habitat is 2 days old, 3 days old, and there's no reason we couldn't add like an AMI target or a VMDK target or an ISO target. Pretty much any bootable, snappy target, anything that you need to package up. As we were doing the Mesos package, Mesos container is really just process isolation. So if you needed to have a running application with a supervisor somewhere, take apart the Mesos one because there's nothing in there. So it's nothing but the application and a supervisor.
All right, so one of the things that we saw when Matt went through that was that configuration file, so his Polypo configuration file. And I said earlier that what if we had these immutable artifacts where we could inject configuration parameters, where we could inject data there. So maybe, Matt, you could inject some change to your Polypo config and just kind of walk us through that.
So we've got this tiny variable. No, I haven't done this one, so.
Oh, all right. All right. That's cool. I can maybe help walk through
yeah,
it if
you
you
can
need to.
me.
Yeah.
FG. So I killed my Polypo. So what is it?
Okay, so you have a couple of options. One of the things that you can do is the way that you can set those configuration parameters is you can actually just export an environment variable. So when you run the Docker run, you could do a Docker run -e, and then you're going to set hab underscore Polypo as the name of your variable. Yep, like yep, just like that. And then equals. And then open up quotes there around that server expire time. Yep. And then set it to whatever you want it to be equal to. And so what do you have? You had it set to 7 days and you just changed it to 1 day. Yep. And now if you just rerun that, that should work if my memory serves correct. Failed to parse the TOML, expected equal, but found EOF. All right. This is good because what I did, oh yeah, that's probably right. Yeah. Ah, beautiful. Beautiful.
So now if we come back to our Polypo and look at the current configuration. Where was that setting? There it is, server expire time.
It's set to 1 day. 1 day. You might not be able to see it. Maybe you can. You can trust Matt and I. It's a live demo, and we're totally not lying to you. It says 1 day. No, honestly, it says 1 day. You can zoom in if you need to. It's totally there. So that's one way that you can inject those configuration parameters. But the other thing that you can do, and you might need to look at some docs to get us through the proper syntax here. I'm not sure. But so the Habitat supervisor from within the studio, you can actually put, so the supervisors themselves run in a gossip ring. So the supervisors are all organized into a gossip ring that allows them to communicate with one another. So from your studio, you can actually inject a configuration parameter into that gossip ring. So you can put a rumor into that gossip ring. The supervisor will see that rumor come in and then will apply it to all of the running packages of that type. So yeah, it's going to be like hab config apply. Yeah, polypo default. Yeah. Oh, you must be looking at docs. I can tell by the look on your face.
Looking at the README.
Yeah, and then a space, and then well, like what version of the config will this be? You can call it 1. Yeah, like 1. And then let's see what's next on the README. Yeah. So then you just probably need to say, yeah, like grab server expire time. Yeah, and you can set it back to 7 days, or you can set it to 4 days or something.
How does this work?
Echo or write that server expire time, like create a /temp config .toml. It should be a toml file.
Oh, okay.
Yeah. So if you just write that out to a toml file, yeah, like test.toml, great. Now you can inject that by just passing test.toml. Yeah. Okay, and so now it got that configuration change injected into the ring as a rumor. The supervisor saw that, grabbed it, injected it into the running container, and then told the container how to restart itself or how to reapply itself. So depending on, let's see, did it work? No, it didn't work. But that's totally how it works. So you can just imagine, quick, like view the source and go to Chrome Tools and change that 1D to a 4D, would you?
Oh, here's what the problem is.
Aha.
We have to hit the right supervisor.
Oh, yes, of course. Hit the right supervisor.
I don't know the command, though.
Yeah, somewhere in there. Put it, yeah, maybe there. Feels right. No. Yeah, so we're super good at this. As you can tell, it's a live demo. But the idea, hopefully you can get it. So hab config apply. Yeah, --peer. Yeah, thanks. --peer. Yep. Or -p.
Yeah, no, that hit join peer.
So that directed that into, and it's still not doing it. It's cool. Oh, is it still applying the configuration? Did it stop applying configuration? So it's joining the peer. Are you in the Hab Studio when you ran that?
No.
Oh, you have to be in the Hab Studio when you run that. It's never going to join the peer if you're not in the Hab Studio. Just go back into the Hab Studio and do all that again. It'll be fine. So this is cool. Like we built. Now I'm out of frame again. I have to walk back over here. Sorry. I was walking away from him because he keeps messing up. I don't want to be associated. He keeps doing exactly what I told him. And some of you joined me earlier today, and you learned that you don't do what I tell you. What do you do instead, Christine? Yeah, you do what I mean, not what I say or what I do. You should do what I mean all the time. Are you doing all right there?
That worked.
All right, so we'll just assume that it worked because, live demo. But this is what you can do. You can inject those parameters into that ring. Maybe we can go back to the slides for a little bit and see like what comes next on the slides because the demo part is going swimmingly. But let's just review kind of from the slideware exactly what we just talked about as well. So we've just built that plan. So we went in, packaging starts with a plan. We launched the studio. We defined our plan with all of the source files that we need. We created our configuration template. We described our configuration defaults using TOML. One of the things that Matt didn't show you was you can describe hooks for certain behavior, like initializing your application, running your application, what happens when you need to run it. What about health checks? How do you know if this container or this application is healthy? You can define your own health check there. We didn't show it, but Matt has created a signing key for his origin. All of these packages, as you did see, are signed so that we know that they're the packages that they declare that they are. We built the artifact, and then we did the post-processing, and we exported it to Docker. So on the next slide, what we talk about then is how that artifact actually gets run. And here's where we kind of talk about that supervisor and the gossip ring that they create. So your artifacts end up in a depot. Your Hab supervisors are going to pull those artifacts out of the depot and then run them. And I mentioned earlier that they can become topology aware. So they understand what are the various topologies that you might want to run your application in. And here we are on day 3. And as is apropos, and this will be the last day I can say it, we have 3 different topologies that come out of the box with Habitat. The first one is a a leader-follower topology. So that's like if you have, Redis is a good example of that, where you want to have a cluster of Redis servers, and you need 3 or more. They'll do election. I become the leader. You become followers. You'll sync data off of me. If one of us fails, we'll have another election to make sure that we have a good leader. And all of that comes built in with Habitat. It's all part of the Habitat supervisor. The other topology that we might have is an initializer pattern. Think about your applications that you deploy. I want to stand up a bunch of applications that all talk to the same database. Well, there's no point in standing up the applications until the database is up. So the database might be the leader in that ring, in that service group. As the database comes up and is available, I can now launch the rest of my application servers. And then, of course, there's the simplest one, standalone. So we are all together, but we don't necessarily rely on one another. Each one of us is an independent entity. So the supervisor can execute a variety of hooks when certain things happen. So as an example, when Matt injected configuration parameters, the supervisor said, oh, there's a new configuration parameter. I need to reconfigure this artifact and then maybe reinitialize it, rerun it, whatever the reconfigure step is for that particular application. We also think a lot about security. We know that sharing secrets is not a solved problem. Sharing secrets in configuration management tools is a real strong challenge for us. So we actually have a way to ensure that these secrets and things that we're injecting into the ring are actually from authorized users only. So as a supervisor joins this ring, we can make sure that they're using the proper key so that they're authorized to join this ring. You can't have like an external actor that joins your ring and says, no, I'm a polypo also, and you can let me in and do the same things and take over your network. So we have that, and then so the supervisors will have a shared key, and then we'll do some other encryption to make sure that like Matt just injected a secret into the ring, or a rumor into this gossip ring. Is Matt authorized to do that? Is Matt who he says he is? We'll check his keys before we allow those things to come in. That slide was supposed to be removed, so I'm not going to talk about that. That's coming later. So this is Habitat's approach. Applications run as distributed, fully automated, and capable autonomous actors. We have immutable applications, but they're flexible and easy to manage because the automation travels with the application. So this is a phrase that we repeat often about Habitat. It's also the first time I've said it tonight, which shows you how often we repeat it about Habitat. But the automation travels with the application. So what does that mean? It means that the application actually knows how to handle itself, but also can easily be reconfigured through injecting configuration parameters and things like that. What do we need to do to automate that? You bundle what your apps need to run and nothing else. Nothing else goes in there. We've embedded automation choreographs. The embedded automation choreographs the application cluster and the topology and behavior. Also think about things like update strategies. If you have a bunch of applications and you want to roll out a new version of that application, how does that go out? Do you do it one at a time? Do you do it all at once? Do you do a certain percentage and then a bigger percentage and then finally it goes to all of them? All of these can be built into Habitat. We have a network with no reliance on external services, no single point of failure. Those supervisors are all running in a ring. And the more supervisors we add into that ring, the more resilient it becomes. And it provides continuous deployment without the traditional application release automation tooling. So you don't have to get into complex systems like Capistrano or some of the other application release automation. And the really cool thing about this, or one of the other really cool things about this, is that the solution is the same, whether what you're building are brand new apps or you're taking existing apps and putting them into a Habitat. So Habitat, as Matt mentioned, will work on any 64-bit Linux after a certain kernel version, so a modern Linux it will work on. If your application runs there now, you can build a plan and put that application into a Habitat, which is pretty amazing. You do not have to change the way that your application works. Your application needs to be able to read a configuration file if you want to take advantage of, injecting configuration changes. But how many of you have ever written an application that doesn't read a configuration file? That's what I thought, right? Of course, they all read configuration files. It's not cloud native in the sense that you have to rewrite your application to make it cloud native. It's cloud native in that you can just put your application, your existing application, into this Habitat artifact format and run it under a Habitat supervisor, and you get all of those benefits. So we're just about to the end. Habitat, here's the elevator pitch. It's application automation that enables modern application teams to build, deploy, and manage any application in any environment, from traditional data centers to containerized microservices. So we just saw a Habitat running in a Docker container, but Matt could have just as easily spun up, I don't know, a Vagrant or an AMI off on AWS, installed Habitat, and run that same package under the same Habitat supervisor. I'm not going to go through that because I'm not, but I can come back to that later if you want. We believe all applications can be autonomous across any platform. That's what Habitat provides. Now it's time for the live demo. Are you ready, Matt? Oh, no, we already did that. Cool. I like to bake that in. So, yeah, Habitat is 3 days old. Here's another really amazing thing about Habitat. It's fully open source. It's free. You can use it right now, and it's yours to use. If you go to habitat.sh, there are a bunch of things there. There's a tutorial, so you can actually build a package. You can build a Habitat in the browser. You don't have to install anything. You can kind of walk through a scenario that'll give you an insight into like putting your own hands on it. There's a tutorial where you can build your own application. The tutorial, as Matt mentioned, it builds a little node application. We'll even show you how to inject those parameters into it. There's a getting started guide, plenty of documentation. It's all open source. At this point, I would like to say thank you, and I would like to ask, what questions can we answer for you? Yes, Paul.
I saw you were calling dependencies. I saw you were calling dependencies by doing core/whatever. So does that mean there's like a supermarket-like thing up there somewhere that has all of these things pre-built and ready for me to use?
There certainly is. So it's at app.habitat.sh. Matt will maybe pull it up in a browser. I don't know. But it's at app.habitat.sh. You authenticate with your GitHub account, and you can go and browse all of the packages that are there. Yeah, and publish your own packages as well.
Awesome. And since I have the microphone, I had another question. With the Hab supervisor, if I have, say, I'm running like Elasticsearch or something like that, and I want to do like a daily job to run Curator to delete all my indexes after older than 90 days, is there a way to say, hey, go and run this in one of my Elasticsearch containers either once a day, or have cron or something do like a Docker exec type thing to do that?
Yeah. What do you think?
I was looking at there's a lovely UI that's broken for search. Sorry, I did not hear the question.
Right. I think cron is maybe the answer.
Cron.
Cron sounds good. I don't know.
Yeah.
Yeah.
What was the question?
I'll tell you the question.
Is there, using Habitat, is there like a Docker exec type thing that can let me run like an arbitrary command in say I've got a 3-node Elasticsearch cluster I'm running in Habitat,
yeah,
and I want to run backups, or I want to delete old indexes like once a day or something like that?
I don't believe that's there. You can enter, so you can enter the shell of the container. So you don't have to like kick off polypo. I could pass it .sh at the end, and then I could be in that container if I needed to debug it. But I can't run any additional commands inside it. I can't, because the PID1 is Habitat supervisor, and as soon as you try to enter it, it's like, yeah, I'm running, and then when you hit Control-C, it's like, I'm not done, and it just restarts itself, and it's going to keep running. I don't know. I don't know if there's currently something that sounds like a handy debugging thing to get into a busted container and poke around at the guts of it without having Hab say, no, I'm still running. But that's not yet.
Probably not yet. Yeah, we got another one here. There you go.
What integration is there with Habitat and Chef? I'm trying to think of a scenario like how you can connect
None.
the two. Okay.
Not yet. So there's actually a Habitat cookbook in development. The Habitat cookbook will do things like pull down a Habitat studio for you, build things, take the artifact that gets spit out, and then you can take the Docker cookbook and take that Habitat the Docker that you just built, use Chef to set up the infrastructure, and then throw the Habitat built Docker image onto the Docker managed by Chef. So Chef is for infrastructure. Habitat is for applications. So
Sorry, go ahead.
I'm not done.
Right.
So I'm actually writing a blog post right now about Habitat and DCOS, Mesosphere, and we have a DCOS cookbook, and I go and stand up a bunch of stands up the master and the followers, and then over here with Habitat, I make a Mesos application and throw it onto that. So there's a nice line, and then when you start looking at those infrastructure, we call them container orchestration. There's also a really clean line of Habitat is going to manage the application inside of that. So if you're working with Mesos, or if you're working with Kubernetes or Docker Swarm or Nomad, Habitat is going to manage the application. How maybe it's a 5-node application. It'll handle those nodes talking to each other, but it's not going to do things like schedule, which CPU it's going to be bound to, or how much storage you're going to get, or which network ports are open to the container. So we're at the container talking to, inside the application only.
The only thing that I have to add to that is Matt just gave you an answer that talked a lot about containers. You could also take that Habitat artifact and put a Habitat supervisor on a piece of bare metal and run that Habitat artifact without running any sort of container. You're just running the Habitat package. So you're running your application in a Hab supervisor. You don't need Docker. Habitat is not a replacement for Docker. Have I said that yet tonight? I think I have. Okay, good. That's all I had.
But it does answer the question of, hey, I have this new application. Am I going to upstart it? Am I going to systemd it? Am I going to run it? Am I going to, which one am I going to use? Well, let's just take a supervisor that's portable to wherever you're going to go. And so we need to, we, the community, and Chef, the company, need to hit these other targets. Like, I want a bootable VMDK. I want a Linux image that just boots and runs an application, and maybe it's not going to be a container, maybe it's going to be a unikernel at some point. That sort of thing is, this is the application and where you want to run it with the minimal effort of building up the environment that it needs to run in, making sure your distro has the right versions of things. Like, let's get away from that.
Mm-hmm.
Yep.
So you're pointing out that there's this distinction between the infrastructure and the application. You're kind of managing more the way the application talks to its components. So the environment that we use where I work at the moment is microservices running in a Rancher environment, which is closely related to Docker Swarm. And the elastic scaling there goes on at the Rancher level. So a service will be defined logically as a container, but the number of instances of the container will scale elastically at the Rancher level. So if they were running on Habitat, so the number of instances are scaling elastically, how does the Habitat ring work in that environment?
So Rancher was one of our launch partners. They had a great blog post yesterday. But so Rancher is a container manager that sits over both Kubernetes and Mesosphere. They announced that at Mesoscon, and so they have a templating where it's kind of like a Kubernetes pod, or what's the Docker equivalent, Docker Swarm equivalent. Anyway, multi-node definition. Like, hey, these nodes together define a service, and so within that service, you would say, well, I've got three of these MySQL containers, and 2 of these app servers, and one, and Rancher or Kubernetes is providing load balancing as a service, and they're going to wire into that and listen on this port. And so within that, you would have, well, that container that is running MySQL, that's managed with that was built with Habitat, and that Docker container has Habitat, and it's going to be listening on these ports. And Rancher would just say, well, here's the environment variables you're going to use. I'm going to pass you the network settings that you're going to use, and Rancher is going to handle the networking between those nodes, whatever security is necessary, and hand it over to Kubernetes or whichever orchestrator is running, and let them do that work. So we're still working with them, but they were really excited about it. The Mesosphere and CoreOS were also launch partners. People who and Google and the Kubernetes. Whatever their foundation are, they were launch partners as well, and Intel was a launch partner. So we've shown it around to a lot of the different container vendors to get their feel for it, and it solves a problem that they see because they don't know what's in those containers. They're like, hey, containers are cool. And everyone's like, yeah, containers. And like, well, what's in it? Like, yeah, containers. And so, it solves that problem. And then they're like, so you got this container. What happens if I need to, restart it? Or what happens when it dies? Well, one of the things we haven't talked about that is coming, it's not coming, it's there, it's just not really fleshed out yet, is monitoring. With Habitat, you can also define how things are monitored and how the logging is captured. So Habitat also is going to expose those things because really we want to make applications as manageable as possible. And the way you manage them is how to pass them environment variables and how to start them, and how to monitor them and how to and logging is part of monitoring. So and how you cluster them. So that's what we're shooting for.
Yeah. So that Habitat supervisor actually has a RESTful API, so you can already start to ask questions and get responses back. Like if I'm running a topology where I have 3 nodes in a cluster, like what's the state of the 3 nodes in the cluster? Which are the 3 nodes in the cluster? And that the Habitat supervisor can return that to you. The other thing that you can learn about your artifacts when it comes to like what's in that artifact, like what's in that container, you can ask the Habitat supervisor, what are the configuration parameters that I can pass into this artifact? And it will show you that TOML file, or it will show you the configuration file that says, hey, here are all of the things that you can pass in there, but it shows you the full configuration file. So in addition to just here are the settings that you can put in there, it will show you the commentary from that configuration file as well. So you can read the comments and understand like, what does XYZ mean when I set it to 53? I don't know, but when I can read the comments.
And you can also do things like query the system and say, hey, I've got this application that uses OpenSSL. Which version is it? Which version of OpenSSL was that running cluster over there built with? And you can get that information out of the API as well. That is a Chef integration that already exists. We've got a Ruby API for Habitat. A gem for that. Yeah. Jay Timmerman wrote it. Question from Paul, or question from Everett?
Yep. So up to the part where you actually like ran it with the supervisor, everything prior to that, to me, it looks a lot like an abstraction for generating artifacts for different platforms, be it Docker or Rocket or what have you. Is that an accurate generalization?
That is a very accurate generalization. We are building 64-bit Linux application full stacks. And that is portable as much as we need kernel 2632 or later. And that's a lot of Linux distros, most of them LTS. And what you want to run it in after that, whether it's a container or an ISO or a VMDK, we don't care. So if you have a Ubuntu pre-seed and you want to slap a Habitat runtime on top of that, that's cool. You could have a bootable ISO that you slap a CD, date myself. You slap a thumb drive into a machine and have it boot your application. You can do that sort of stuff if you're building appliances. And then hey, I got this slim distro from my vendor, and it boots into my application that I know everything about that application.
It's like a Packer for all the things.
Yes, Packer for all the things. So pretty much any target that Packer's currently hitting is something we should do. I mean, honestly, like there's no reason we can't add all those. It's just it's open source. So it's going to take a while.
Sure. Who had the next question? And thanks again to CZ for the awesome barbecue.
Yeah.
So a comment, then a question. The comment is, it seems like you've got a really interesting way to solve building Docker containers from scratch and building very small containers for things that aren't Go. Because it's easy to write a from scratch container for Go, but other stuff like C and other compiled stuff is really tough. So that's really cool. The question I had was, with your Habitat forms a gossip ring and talks to each other. Is there thoughts of supporting just being a client for something like etcd or console rather than forming that cluster yourself? And also, are there thoughts around being more than just key value store and doing stuff like the health checking that console does or the DNS that console does?
I'm going to defer to the FAQ and stuff. It kind of goes into a little bit of that, but I do know that we investigated etcd and console, and I can't speak to the exact reasons we didn't use them, but they did not fit the use case that we're using. I don't think we plan on. I don't have a good answer, but I've heard Adam and Adam can expound on that, and I think that's probably something that we should comment on in the technical FAQ. Like, well, Rust is cool, okay, whatever, but why did you guys not use an existing off-the-shelf thing? And they have their reasons. They kicked the tires on those tools, but I don't know the exact reasons. We did not invent a whole new protocol or anything like that. We took an off-the-shelf gossip protocol called Swim. We had to implement it in Rust, so we did do that. But we have a few people who know about distributed systems on staff, and so and we've committed all that upstream, and the Rust slang guys are happy to see us because we're now the #1 Rust project, at least turning on GitHub. And then on the leader elections stuff, we're using the Bully protocol, which is also an established standard. And there are reasons, and that's about where my distributed systems knowledge stops. Yeah. So yeah, that's something we should add to the FAQ at some point. Point at the box. Oh yes, we have lovely T-shirts. So everyone who ate barbecue can have a T-shirt.
Until we run out of T-shirts.
Until we run out of T-shirts. I don't know how many we have. So.
I don't know either. So about 15. All right. So here's how it starts. If you spoke into a microphone tonight, you get first dibs on a T-shirt.
Woohoo!
Anyone else have a question they want to ask?
Yeah.
Yeah. Sean has a question. It can't be, can I have a T-shirt?
Can I have a T-shirt? No. So the very first thing that I decided to try with Habitat was to get Jenkins running. I don't know why. I just did. And layering that on top of what Thomas kindly linked me to, one of his colleagues got a Tomcat setup running, is interesting because the Jenkins Docker file just says from Java, so it starts from that point already. Have some of the demo apps that you guys have been running internally been that kind of layered approach? Because like the Elastic thing, that's now a binary installation, right? So
I think the Elastic.
I guess one way to ask the question with maybe an easier way to answer would be applications that need something more complicated than Node to run on top of.
Sure. Yeah, I think the best way for us to answer this, certainly the best way that I would answer this is I would do probably what Matt's about to do and go to Habitat, go to Habitat. It's in there. You're looking for the plans? Yeah, in Habitat, there's a plans directory, right? Oh, example plans? No, you want to go to just Habitat. Yeah. Oh, I don't know where Elastic is. Elasticsearch, yeah. So it's using core server JRE. He's pulling
pulling in an Apache Tomcat, which pulls that in.
So that's running the jar directly as opposed to spinning up Tomcat and then running the Elasticsearch WAR.
Package service.
Is that maybe in go back to the Elasticsearch directory and hooks?
Oh, yeah. So there's an init and a run, and then a run.
No run here.
The run is in the plan, I think. To build package service run here on line 12. Yeah, it can be, but if it's something simple like this, you can just override package service run, or you could have your own hook that is a run script that's going to be a little more complex than a single line.
So the tutorial is a run. That's why I was lost. Yeah, so
This is what I get for trying to do Jenkins on day 2.
no, so that's actually a good point. We have a Slack channel. Slack.habitat.sh, is that what it is? It's probably, or habitat.sh Slack. Anyway, there's like 250 people already in there, and on Hangouts, there's another channel in there that has a fair number of folks on it. Yeah, so community, we got a Slack, we got forums. Which I need to sign up for.
So based on discourse, you can come in and ask some questions there.
Yeah. So yeah, it's still kind of new, but I'm sure you can find people doing Java applications because that's a really important target. I mean, if you've got all these, existing applications, and you're like, how do I get these into the cloud, into containers, into more modern infrastructure than where they're currently running? And you can't just say, well, just rewrite that thing, because I was talking with a bank, and they're like, Chef, that's cool and all, but what are we going to do about like all this stuff that I want to move into containers? And like the sales guy, like he almost jumped out of his skin. He's like, I got to tell you about Habitat. I was like, you're not under NDA. But this was like 4 months ago. And so he told them about Habitat and how you can take your existing Java applications. We'll figure out, how to run them exactly, but moving them into containers is a good first step. So we actually went to a large CRM vendor based out of Germany that has a very large database that runs on Java, and we showed them Habitat, and they're like, well, that's cool, but our application is 40 gigs. I'm like, it's okay. You can put that in a container too. And so, we put, what's the name of the database?
You can't say the name of the database.
Oh.
Yeah. Don't say the name of the database.
All right. So this large German vendor who has an open source database that, starts with an H and ends with an Anna. We Docker, we put that into Habitat, and they're like, wow, you made a 40 gig container. That's impressive. But we wanted to run it clustered. And that's usually a 2-week services engagement, and took 30 minutes. So that worked out well. But you can definitely run enterprise applications in containers. You just need a machine that can handle multiple 40 gig containers running at a time.
So Matt, are there are there any thoughts on integrating Habitat and delivery?
Absolutely. So you're probably saying, so what's your angle, right? So it's open source. We just open sourced everything. Everything we've shown you. If it's not open source today, it will be soon. Things like the depot, at some point, we will open source that. We will have a build service eventually, so you can have something in the cloud that builds things that gets uploaded to it, and you can just pull down the binaries without building them locally. Is that working? Not yet. It broke. It was working. So it's left out of the release, so we have to update the slides. But build service is coming. You'll be able to run your own. You will be able to run your own depot. We're publishing, well, that other tab, we're publishing to apps.habitat.sh. You will be able to run your own, just like GitHub. We've got public repos, you've got private repos, or you've got GitHub Enterprise where you can run it in-house. You can do all that. It's all going to be open source. Our angle is delivery and the Chef workflow and things like compliance. So the way we make money is we sell things to enterprises that they want to pay for. And the things that they want to pay for are compliance and visibility and everything that happens. And so Habitat, Chef, Inspect, those are all completely open source, and we want everyone to use those. And then when you say, I've got this tremendous amount of data funneling through my enterprise, and I want to know who uploaded which package at what time, and I want to push that into Splunk, that's where we come in. So that is our commercial upsell, but there's no catch. It's just everything we've shown you works really well with everything that we do commercially. So, but yeah, we want everyone to use Habitat. We think it fits kind of a big niche that wasn't filled, and we made it Apache because if it wasn't Apache, we showed it to you, you'd go write it yourself.
And so I think that's probably all the time we have for questions for tonight, but I do want to thank you again for coming out. I know this was on a very short notice, so thanks for that. Thanks again to Paul for the amazing barbecue. Yeah, that was awesome. What's that? Yeah, of course. And thanks to Rackspace for hosting us at the last minute. That's awesome. Yeah, and we really do want you to get involved with Habitat. Like, put your hands on it. Go try to build a package. And just like anything else, like, you're going to get better at building packages if you go and read some of the plans that are there. Like, go learn from the plans that exist today. Share with each other. Join the community. Join us in the forums. Join us in the Slack. Let's have those conversations. We love the feedback that we've had tonight. Thank you for all the great questions. Some of the questions Matt and I have thought about before. I don't know if it came across, but some of them we hadn't even considered before. But I think, we did a pretty good job of answering the ones that we could. Yeah, so thanks again for coming out tonight.
And if you didn't get enough of this tonight, the Austin Cloud User Group next week, we'll be talking about Habitat. The Mesos User Group later this month, we'll be talking about it. And ChefConf is next month, downtown Austin. So if you... and the Texas Linux Fest, we'll be talking about Habitat. So you're going to get a lot of Habitat in Austin the next 3 weeks. Yeah. 4 weeks. But yeah, ChefConf, downtown Austin, next month.
Stickers in the back. Habitat stickers, so you can get Habitat stickers. You can get info about ChefConf. All right, I'm going to give you one more chance to ask a question. Yeah, sure.
Where can we find this video after, or the slides?
Yes. So we'll make the slides available. We'll probably what will probably happen with the slides is I'll turn them into a PDF and put them onto my speaker deck, and then I'll link them in the discussion thread of tonight's meeting. So you'll get a link to them from there. And then Rackspace is going to post these to YouTube.
Yeah, we're going to post them to our YouTube channel. I'll put a link in the meetup notes.
Yeah, there you go. And the other thing, just on the topic of videos and Habitat, if you go to this Why Habitat link here, and you weren't able to tune in to the announcement video live stream that we did on Tuesday, you can watch it here. You can watch that webcast. It's about an hour with Adam Jacob, including live demos and lots of Adam Jacobness and lots of boop. Yeah, and if you won't know what that means until you go and watch the video, so you should go and watch the video.
Also much more, and Adam goes really in depth into a lot of the topics. So.
Yep. Cool. We said we were going to stop, so we should stop.
Stop.